Hi folks, Michael McDonald here with you again. This is my second in the playlist series of PGIs, or Preparatory Ground Instruction. Those are the little lessons that happen usually on a whiteboard or in a room with the student and the instructor just before the flight, going over the knowledge of the lesson to come. So this is number 2 that I'm doing. It's taxiing. Now, some of you may say, well, taxiing, do you really need to have a preparatory ground instruction lesson on taxiing? Can't you just hop in the plane and wing it? Well, even with the tricycle gear airplanes that are relatively easy to taxi compared to a tailwheel airplane, there are all kinds of factors to consider. And it's actually quite difficult for most new pilots to get used to taxiing. And even as they go through their flight training, I spot errors all the time that accumulate. So there's all kinds of things to talk about with taxiing. And so let's just get right to it. I'm going to share this PGI that I have here set up. All right, so exercise 4, taxiing, preparatory ground instruction. So there is, like I said before, there's a structure to PGIs. So I'll just follow the structure. So we have an intro. I might give this intro during a PGI with a student, or I might just jump to the next section, but I'll read the intro to you. Taxiing is often overlooked as a key aspect of airmanship. This is true. Although taxiing may not be the most glamorous part of flying on first look, seasoned aviators can spot an inexperienced pilot or a pilot with a plethora of poor airmanship techniques within seconds while observing them taxi. So if you want to be a precise and safe pilot in the air and gain the admiration of the seasoned pros or your instructor or your examiner, you may as well get it right on the ground first. I have to agree. It's all about airmanship, even on the ground. So we'll look at situational awareness, maneuvering skills, communication, and environmental/safety factors for ground and taxi operations. All right, so you can see there's a little bit more to it than just driving a plane on the ground. So then we have the TKT, which is a threshold knowledge test. So this is something that instructors do to get a sense of what the knowledge of the student is. So it's just a few questions, which really helps guide the rest of the PGI and the flight lesson itself. So a question would be, for example, how is a conventional airplane steered and maneuvered? I say, when they say conventional, they mean a tricycle gear airplane. And of course, that would be the use of the rudder pedals, which are linked to the nose wheel as well as the rudder. What are the 4 most common mistakes people make while taxiing an airplane? Well, there are 4 common mistakes. Improper use of brakes, either not using enough brakes or adding power while holding the brakes on or riding the brakes. These are very common things that happen with ab initio pilots as they're learning how to taxi an airplane. Improper use of power, which of course is tied to the improper use of brakes. Lack of situational awareness. Airplanes are often not designed really great for visibility. You got the wings, the high wing airplane blocks visibility. The windows are small, often not in the best shape. And not only that, when you're new at flying, everything becomes tunnel visioned as you're trying to learn a new task. So we tend to only be able to handle so many things in the brain at one time when we're learning something new. So tunnel vision occurs. And of course, poor communication techniques. So those are the 4 most common mistakes that people make while taxiing an airplane. Those of you who may remember those mistakes that they made and maybe still do make. I've seen commercial students make those mistakes. So it's not so uncommon, but it's relatively easy to fix. But you'd have to sort of work, like an instructor would have to work with a student over time to fix those 4 things. Maybe not all of them in one session. What environmental elements influence taxiing issues and practices? Well, what would you think would be an environmental element? Perhaps wind. An airplane is basically a kite. In some ways, powered kite. And the wind on the ground affects an aircraft just as much as the turbulence in the air. So there are techniques to mitigate factors such as wind that affect the ability of an airplane to taxi. And of course, other environmental issues would be like ice, icy ramp or an icy taxiway, rain, visibility, mist, fog. All right, so visibility and controllability of the airplane. Why is communication important when taxiing? Well, at a non-towered airport or a towered airport, communication is very important. Like, people get busy in the cockpits, and sometimes like that tunnel vision or complacency kicks in, and collisions could occur or incursions could occur on the taxiway, on the ramp. So communication is really important. Communication with ground or communication with other airplanes. And then the fifth question I would ask in this TKT is, how should you familiarize yourself in an aerodrome environment? Well, I'm kind of hoping that the student says that they're going to study the aerodrome in the Canada Flight Supplement. That would be a good answer. So they can get all the data that they need: the length of the runway, the orientation of the runway, the taxiways, the ramp, the procedures, the frequencies, all of that stuff. So using the CFS is important. All right, so then we get to the what section. Well, what are we going to talk about? So aircraft control and obstacle avoidance skills is sort of the heading of this section. And again, this is a question answer format. And generally these things should take only about 20 minutes. It's longer with me because I'm going into a little bit more detail and justifying the questions as we go. So how does a pilot familiarize himself in an aerodrome environment? Well, you've got the Canada Flight Supplement, all right. Visual, looking, walking around, having a look. Questioning people who fly at the airport, very important. Looking at the notices to airmen. Listening to the aerodrome traffic information system or automated. It's funny. I can't keep all the acronyms in my head, but ATIS, right? So that's where you get the weather and airport environment on frequency just before you taxi. And then there may be local procedures that are not published, and they would be something you pick up from people who are kicking around the airport, and they'd be in the ATIS as well. All right. Automated Terminal Information System, ATIS. How is the standard tricycle airplane steered? Well, we use rudder pedals. The rudder pedals are linked through a bungee system to the nose wheel of the airplane in a Cessna. For tighter turns, we can use differential braking. So each brake is independently operated by pressing at the top of the foot pedal. We need to avoid overusing the brakes by keeping our heels on the floor. Keep your heels on the floor. If you're riding the rudder pedals like this, you have much less control, and you have a tendency to push forward on the tops of the rudder pedals, which are connected to the brake lines. And then different surfaces require different amounts of braking. So there's a subtlety to that you need to be aware of. So those are the ways that you steer the tricycle airplane. And to a certain extent, the tail wheel airplanes are similar. You have the tail wheel, which may be either locked or controlled in a newer airplane, controlled by the rudder pedals, and then it can lock or unlock. And then even older airplanes, you may have a free flying tail wheel, where you're really using power and the rudder, but that's less common, obviously, unless you're flying a very old airplane. We're looking at a linked tail wheel, but then you've got your nose much higher, and your visibility suffers even more, and it has a tendency to oversteer at first before you get used to it. But we're concentrating on tricycle gear here. All right, so you need to be prepared to deal with soft and unprepared surfaces. All right, so we use a technique of back pressure on the control column all the way back, which is another tail wheel technique too, but all the way back. So the elevator is up all the way. And then when you apply power, it lightens the nose wheel. It lightens the grip of the nose wheel on the surface. And so it makes the nose a little bit lighter, easier to steer. And then on these rough surfaces, once you get going, you've got inertia. Okay, so you want to use that inertia to help you steer, and you have to sort of anticipate, like say on a rough or muddy surface, how quickly an airplane could be bogged down if you're just starting, stopping, and not using inertia. And actually inertia works on hard surfaces as pavement as well. So understanding that there's an inertia, once the power is up and the propeller is spinning fast enough to move the airplane forward, the airplane now has an inertia that you can use. If you're riding the brakes, then you're not taking advantage of inertia at all. Okay, because you can't get inertia when you're riding the brakes. So it's kind of the technique is linked. And so that's why you see braking techniques. So inertia and braking techniques are linked. What safety and operational checks can be made during taxi? Well, we have the anti-collision lights on the aircraft. We want to do a brake check. So the brake check is once you start the aircraft moving, before it gets going to the normal taxiing speed, you can just tap the brakes and see if they work. You don't hold the brakes down while you've got the power. Reduce the power again. Once you get that inertia and the aircraft starts rolling, pull the power back and just tap the brakes. Make sure that they're working. If there's one brake working, you'll notice a swing. If they're both working, you should be able to just slow down without yawing. So, of course, you want to avoid obstacles. What kind of obstacles are we talking about here? Well, anything really. But what most common is, little pieces, little concrete tie downs that a propeller might strike. It could be loose objects on the ramp or the taxiway that can get blown and propelled by the propeller and cause damage. Things like water, believe it or not, a puddle of water under the propeller, if you're running up the propeller or even idling, that water is very incompressible and it'll pull the water up from underneath the propeller in a vortex. And that water can actually damage the propeller because the water is not compressible. So it's just like, when you do a belly flop, you realize just how uncompressible water really is. So the same thing can happen to the propeller. So don't do prolonged idling or running of the airplane over a puddle of water. Be aware of your clearances, where the clearance between the propeller and the ground. And then your propeller wash can cause all kinds of mayhem. Like, a classic example is you pull an airplane out of a hangar, the tail's still pointing at the open hangar door, and you fire her up and pandemonium ensues in the hangar, right? It's like a big wind trap and you're just blowing wind into that hangar and at the very least messing it up, at the worst damaging equipment. And then other things like the use of the parking brake, right? When and how to use the parking brake. A lot of people ignore the parking brake, especially in Cessnas and the Pipers. I encourage my students to get used to using the parking brake during the initial startup of the airplane and during the run-up. And then once we are on the taxiway or holding short of the runway, we don't use the parking brake. We just have the feet on the brakes. The use of chocks. So if we're keeping the airplane from rolling, being blown in the wind, and tie down. So it's all part of this ground handling of the airplane and taxiing are tied together. So those are subjects that we discuss. And of course, I ask questions. All right, so we'll talk about managing the wind as that environmental factor. So using aileron and rudder. Okay, so what I call that is quartering. Okay, so there are 4 basic directions that the wind can come from to an errant airplane waiting to go or taxiing along. There would be the front left, the front right, the rear left, the rear right, and of course the direct front and the direct rear of the airplane. you get enough wind and enough gusts, it's going to try to lift the airplane under the wings. Or in the case of the empennage and the rudder, it's going to try to cock the airplane or yaw the airplane. Okay. So we have a technique which is readily available to view in all of the flight training manuals from the ground up and on the internet of the use of ailerons and elevator position to mitigate the effects of gusts of wind or strong winds that may be coming from an inopportune direction while you're taxiing. All right. So we talk about that. So basically, if the wind's in front of you to the left, then the elevator should be forward and the aileron should be into the wind. Or even neutral with the elevator is fine. And that if the wind's from the front right, then the ailerons should be steered into the wind again. So that right-hand aileron is up, which means that the wind would tend to push the wing down instead of getting underneath it and lifting it, thus destabilizing the airplane, potentially lifting one wheel off. Same with the front left, so you get that aileron up. And then to the rear, to the left, it's the opposite, because now the wind's coming from the back. You want to have that aileron down so that a strong gust does not lift the wing, but actually pushes it down. So you go opposite of the direction with the aileron. And you want to make sure that the elevator is forward so that the elevator is in a downward position so that the wind doesn't get underneath and lift the tail. Okay. And then if the wind's from the rear right, then you steer opposite. So you're steering left, elevator forward. If the wind is coming straight on from the front, then you have neutral ailerons and neutral elevator. And if the wind is straight from the back, then you want to have the elevator down and neutral ailerons. Okay. That's a way to always remain in positive control. All right. When you're managing with wind, don't overbrake. Use the energy, use the inertia and energy that manage the energy of the engine, and keep your throttle use smooth and determined, and manage your speed. Right, you don't want to get going too fast, especially in gusty, windy conditions. Okay, so that's basically that. Then we talk about communication. So what we want to do is we want to see and avoid and communicate. So you need to have a proper lookout. Doesn't mean you have to exaggerate your head. I see a lot of students trying to do a proper lookout and they're overdoing it. All I want to know is that you're aware of what's to the left, center, to the right, and when necessary, what's behind you. Make sure you use the proper frequency. If you're in an uncontrolled airport, make sure you're using the proper ATF frequency. If you're at a controlled airport, you want to use the ATIS so they have the information when you contact ground. And if there's any marshalling going on, you want to know the basic marshalling signals. In terms of communication, when you're approaching the runway, you'll often be required to read back information. The most critical thing to read back, and the really only required item to read back, is the hold short requirement. So for example, if the ground says taxi alpha, hold short runway 26, then you must repeat taxi alpha, hold short runway 26, not just Roger or taxi alpha. They're going to want you to affirm that you understand that you need to hold short of that runway. So follow their instructions, do the readbacks. Hold short to 200 feet from the runway at an uncontrolled airport. If you can manage that, that would be good. You know, you don't want to creep right up to the edge of the runway. You don't necessarily know that the landing aircraft that you might be waiting for is having some difficulties with crosswind and may move to one side or the other of the runway, thus creating a dangerous situation. Right? Of course, you've got to deal with people, people, especially at uncontrolled airports. You could be dealing with cars, people, animals, domestic or wild animals. And you need to communicate clearly of your intentions. And if you have questions, either with ground people or tower people, or other aircraft in uncontrolled airdrome, speak up with your questions. Don't clog up the airwaves, but clarify it before you make a move. Right. So like when you're entering or crossing the runway, you want to watch for airborne traffic. You know, it's particularly difficult with a high wing airplane, because you can imagine you're trying to look to the right and the aircraft may be above the position of your wing. That's why being back further really does help a lot. Be aware of wake and rotor turbulence, because these are safety considerations. Like helicopters create very bizarre rotor turbulence. And of course, large aircraft and even small aircraft, or the aircraft the same size as your typical GA airplane, can create enough wake turbulence to upset you while you're taxiing on the ground. So again, you can even use a quartering technique that I was talking about earlier in anticipation of rotor wash or wake turbulence from another airplane. Again, I ask for questions, and then we go into the safety factors. And it's just basically a recap. So don't forget, you want to see and be seen. You want to maintain a listening watch on frequency and communicate effectively. You need to be in command of the airplane at all times with positive control. So again, it's that quartering, but also using inertia, not overusing the brakes, knowing when and how to use differential braking, knowing how to manage inertia on rough surfaces. Okay, so command of the aircraft at all times, smooth power changes. Okay. So basically what we come down to is that good airmanship is not just in the air, it's on the ground as well. It always puts safety, efficiency, and courtesy first. When you get flying, you start to find out how wonderful it is to fly in airspace populated with courteous pilots, as opposed to clued out or just downright rude and bully pilots, and they do exist. Don't be one of those people. If you are one of those people, that's a human factor that you need to consider. It's a personality trait that you might want to work on. We can all share the airways. We can all be courteous, and that includes in communications with the ground and tower people. They're overstressed and have a lot on their hands too. So there you go. That's the taxiing PGI. A little longer than I would do it with a student, but that covers all the bases. So I hope you found that useful, and stay tuned on this channel for yet more videos. And I look forward to seeing you again. Tailwinds.